Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to continue our discussion on overlay by talking about Intersect, which is the first one of the overlays that we're going to talk about. So Intersect works almost exactly like Clip did. And remember back to Clip with the geometry, right, where we had A, B, right? And then by overlapping them like this, right, we had this new piece of geometry here, which is the area of overlap that I'll call C, right? And if you remember back to the previous video, when we talked about, we're not worried about just the geometry, but also the attribute table, right? We have these attributes. So the attribute table for A, with its variable, right? We have the attribute table for B, right, with its attribute, with its variable, right? And then when we run the overlay analysis, right, we got a new attribute table that had the variable from A and the variable from B. And so what happened was, right, anywhere they overlapped, right, so A is going to keep the values for A, but since it doesn't overlap B, there's no attribute for that. B is going to do the same thing, right? So it's going to have nothing for variable A because it doesn't overlap A at all, right? But it's going to keep B. And then, right, C is going to have attributes for both, right? And we already kind of looked at, this is the exact same example we looked at in the last video. But like I said at the end of that video, the particular type of overlay analysis that you do is going to determine which one or more of these rows we're going to keep. And so with Intersect, what we're going to do is we're going to keep only the geometry that overlaps. Right? Only the geometry that overlaps. So this is similar, this is basically the same thing as Clip. Right? It's Clip, but we're keeping the attributes. So in this case, right, if we were to run Intersect, we would get rid of A and we would get rid of B, right? So the resulting geometry here would just be that little piece that's C. That's what Intersect would do, right? It only cares about the geometry that overlaps, and the resulting attributes get combined. So you end up with a smaller overlap geometry and attributes from both of the data sets. So hopefully that makes sense. Let's take a look at a slightly more clean example. So here we have two data sets, A data set in green and the B data set in this sort of purple dashed here. And we have two different attribute tables, the A attribute table with its variable and the B attribute table with its attribute, right? And so if we were to run Intersect on this, the pieces we care about are only the pieces where they overlap. So that's going to be these four areas that I'm highlighting in red here. Right, so we would have a new data set called C. So we'll have 1C, 2C, 3C, 4C, right? And so if I click through, right, I may have numbered them differently, but you see the same result, right? So this area here is the same as this area here, right? This is 1C, right? So it is doing the exact same thing into geometry that Clip was doing. But again, because we're doing overlay, there's another step here, and that's the attributes. So if we look at the attribute table, right, again, just to kind of keep track of stuff here, right, this right here, this is 1C, right? And so in this case, right, 1C's attribute is here. So you can see that 1C, which is this, overlaps or is created by the overlap is probably a better way of saying that, right? Is created by the overlap of 1A and 1B. So because it's made from the overlap of 1A and 1B, it takes the attributes of 1A and the attributes, I got really messy, of 1B, right? So the new feature, right, the new geometry is 1C because it's the result, right? It has the 1A variables, plus the 1B variables, because that's the two pieces of geometry that made it up. So just to kind of illustrate the point one more time, let's look at what turns into 2C. Actually, let me change color. Yeah, right. So let's go ahead and look at, right, this geometry here, right, 2C. Right, so 2C in the output, right, is made up by the combination of 1A and 2B. And if we look at the attribute table, right, we'll see, right, that its OID is 2C because that's the new geometry that got made, right? But it has the attributes from 1A because that's the first data set in the overlap. And it has the attributes from 1B because that's the second data set in the overlap. So hopefully that makes sense. Again, all we're doing is overlapping the data sets. When we run Intersect, we only keep the new pieces of geometry that represent areas of overlap. And then we simply combine the two attribute tables, keeping the records of whichever pieces of data were involved in the overlap. So for 1C, it was coming from 1A and 1B. And for 2C, it was coming from 1A and 2B. Hopefully that makes sense. So let's go ahead and look at another example. So in this example, we have houses with owners, right? So these polygons, these green polygons, these are farm fields. It has an owner. Let me switch back to, right? We have an owner and we have a crop type. Then on top of that, right, we have a point data set. So these purple things are points, right? And we have the model of the type of sprinkler for the irrigation system and the distance at which that sprinkler is rated to actually irrigate crops. And what we want out of this is a new data set with the sprinklers that includes the owner and the crop. So we want to know who owns this property the sprinkler is on and what crop type that sprinkler is watering. And if we run Intersect, right, what we get out are the points, right? Because points and polygons can only overlap at a point. So that part should be pretty straightforward, right? This point here is this point here, right? But more importantly, because we did Intersect, right, again, we have the attribute table to keep track of. And if we look at the attribute table down here, right, again, just keep track of what's overlapped in the original data sets compared to the output, right? So this output here represents the overlap of the first sprinkler, right, which is the type 1 with a rated distance of 75, overlapped with the first farm, which is owned by Shaggy and growing corn, right? And if we look at the output, that's exactly what we have here, right? We have owned by Shaggy, growing corn. It's also the first sprinkler, which means it's a type 1 model rated for a distance of 75. Just to jump down here and show you what happens in the case of 6, right? So that's this one here, right? 6 is made by the combination of the 6th sprinkler, which is a type 3 200, and it happens to be on the property owned by Scooby that's growing wheat, right? And so if we look at here again, right, we know it's the 5th property, it's owned by Scooby and growing wheat, and we know it's the 6th sprinkler, and it's a model type 3 rated for 200. That's all Intersect is. You're keeping only the overlapping geometry, and you're just mashing the attribute tables together. So let's go ahead and quickly do a review question for the type of question you're going to come across on a quiz or an exam relative to Intersect. So in this case, right, we have complete the table based on the Intersect operation given the following data sets and the results. So basically sort of a fill in the blank type question. So I would encourage you to pause the video, take a look at the question, and then think through what the answer would be. Okay, so let's go ahead and go through these together. We have 1C, and we need to fill in the type. So again, all you're going to do is you're going to go, the way I like to do this is to think back of what geometry is 1C, right? 1C in this case, right, is the overlap between 1A and 1B. So that means that we're going to go down to the attributes and we're going to look and say, okay, we're missing type, which comes from the A attribute table, and we're pulling the attribute type from 1A. So we're going to go to the attribute table for A, we're going to find 1A, and we're going to grab the type, which is residential. So this is going to be residential, right? So the second question is asking what is the OID from the A data set that is comprised of 2C. So again, looking here, 2C, right? 2C is going to be, right, that's 2C. So pretty quickly, just visually, we can tell that that should be 2A. Right. The next one, so we're switching from the A attribute table to the B attribute table. And so if we look at the B attribute table for 3C, again, the geometry of 3C is going to be this. And so looking at the OID, again, we can see that this is simply 1B. Okay, for 4C, I'm going to show you guys a slightly quicker way to do this. For 4C, right, we have a blank here, and that's the name attribute from the B table, specifically the 2B row. So we're going to go to the B attribute table, we're going to find the 2B row, and we're going to grab the name, which in this case is Conklin. Right. And then finally, doing that same sort of logic, 1A, we're going to go to the A attribute table, we're going to grab the 1A row, and then we're missing the address, so we're going to grab 42 Ash. And that's all there is to this sort of fill in the blank type question. So hopefully that makes sense. And as always, if you have any questions, please reach out. Thank you.